Hi, welcome to week 2. This is Unit 1 Notes, the Universe, the Big Bang Theory. Astronomy is the scientific study of the universe. It includes the observation and interpretation of celestial bodies and phenomena. Cosmology is the study of the origin, the processes, and evolution of the universe. All stars give off an entire electromagnetic spectrum of energy. This is going to be studied more in your gizmos. Most of the energy waves we have are at the far left as you're looking at the screen. The radio waves, the microwaves, and then the visible energy, infrared. And then when you get to the other side, the ultraviolet, X-rays, and gamma rays are the ones that can start hurting you. Our eyes see only a small portion of the electromagnetic spectrum called visible light. Visible lights makes up the colors of the rainbow: the red, orange, yellow, green, blue, indigo, and violet. You may have learned this as Roy G. Biv. The Doppler effect is important because this is how scientists measure whether a star is coming towards us or moving away from us. So the Doppler effect is an increase or a decrease in the frequency of sound, light, or other waves as the source and observer moves towards or away from each other. A redshift is the object is moving farther away. The light moves into the red end of the spectrum, and its wavelength gets longer. A blue shift, the object is moving closer to you, and the light moves to the blue end of the spectrum, and the wavelengths get shorter. So there is a thing about that. Okay. Is this moving towards the observer or away from the observer? It's moving towards the observer because the shift is towards the blue. This galaxy is moving away from the observer because you can see the shift is towards the red. Again, normal, and then when it moves, normal, and then when it moves, try to guess which way it is going. The Big Bang Theory states at one time the entire universe was confined to a dense, hot, supermassive ball. Then about 14 billion years ago, a violent explosion occurred, hurtling this material in all directions. The Big Bang supporting evidence is this: most stars and galaxies in the universe show a shift in the color spectrum to the red when observed from a telescope on Earth over time. Most galaxies are moving away from Earth, then this would support the theory that the universe is expanding. They would not be moving towards us, they would be moving away from us. Hubble's law, which is also part of your gizmos, states that galaxies are retreating from the Milky Way at a speed that is proportional to their distance. So if you look at a loaf of bread that's rising with raisins in it, it kind of gives you that dimension. It's hard to see, but you can see that we're moving apart. The second supporting piece of evidence is that the universe is full of cosmic background radiation, or CMB for short. It's a faint glow of light that fills the universe, falling on Earth from every direction with nearly uniform intensity. So it's just like all this stuff is falling on us. Cosmic background radiation tells us even more about the universe. It tells us what we can't see in most of the universe. 4.6% of the universe is made up of normal matter or atoms. This is what we can see, what science knows and understands. Everything we can't see is called dark matter, or it's called dark. 24% of the universe is made up of dark matter. 71.4% of the universe is made up of dark energy. So dark matter is matter that gives off no light but does have gravity. Dark energy is a force that opposes gravity and is pushing the galaxies apart and may be causing the acceleration of the universe expansion. And there's a pie graph of the amounts of energy. The Big Bang supporting evidence, number 3, the universe has a higher amount of hydrogen and helium, the light elements, than other elements. Everything else is considered heavy elements. So hydrogen and helium are what we're made up. Hydrogen is right here and helium is right there. The Big Bang nucleosynthesis, the elements of hydrogen, helium, lithium, were created shortly after the Big Bang. Stellar nucleosynthesis, all elements heavier than lithium form in a star, or when the star goes to a supernova. And there you see the element formation in the element chart. What will happen next? Scientists believe the universe will follow 2 possible paths. Number 1, the universe will expand forever. That's one that's favored by most of our scientists. Or number 2, the outward expansion will stop and gravitational contraction will follow. That means it will fall in on itself. If there wasn't a Big Bang and the universe was just created as we see today, then science would expect us to see the universe, would expect to see in the universe no cosmic background radiation, no red or blue shift, every galaxy stays in the same place, and 3, all the elements on the periodic table would be found in the same amounts because it was all created at the same time. And we know that's not true. Major scientists whose work helped create the Big Bang theory: Albert Einstein, who had the theory of general relativity; Edwin Hubble, astronomer who discovered the redshift; Robert Wilson and Arno Penzias discovered background radiation.